Hi everyone, Happy New Year. Welcome to the Art of the Possible series. I'm Nihali Nyogi and I'm a Principal Cloud Solution Architect at Microsoft. Today we kick off our first session for 2025. I'm joined by a few of my amazing colleagues from Microsoft. I have Cynthia and Adam, who are global black belts focused on Azure networking. I have Shri, who is a senior technical specialist, Cal, who is a cloud architect, and we also have John Gao, who is a Cloud Alliance architect from Checkpoint. Thank you all for joining and being available. So some background on the session. Cynthia and I did an ISV series last year, and this video will be an extension of that. Today, we will be sharing a real customer scenario. I'll start with reviewing the official Azure documentation, then we'll review the architecture and problem statement, followed by an awesome demo and troubleshooting tips from John from Checkpoint. So let's jump to the official Azure documentation. So what you see on my screen is the official Azure documentation for the scenario that we're going to cover today. The scenario is to secure the traffic destined to the private endpoint in Azure vWAN. Of course, the Azure documentation talks about it with the routing intent with the native Azure firewall. In today's discussion, we will be using the integrated checkpoint firewall in the design. So the way this documentation is structured, again, it's from the perspective of Azure Firewall, but it talks about network rules and application rules, and followed by the architecture and troubleshooting. The reason this scenario becomes interesting is because there are few moving parts. There is DNS implications. There is also routing bits involved when it comes to private endpoints. There is always that /32 that gets injected. And then, of course, with private endpoints, there are DNS implications as well. And lastly, there are firewalling and SNATing implications. So we'll cover all of that during our sessions. So with that, I'm going to jump on to my draw.io and we'll go over the architecture. So what you see on my screen is a very classic vWAN, multi-region vWAN architecture with routing intent. And so these icons, as you know from our previous sessions, routing intent is enabled. And you could see that we have Checkpoint as the integrated firewall NVA within vWAN. So this is our starting point. And imagine that in this particular scenario, we have a customer that has PaaS services in Azure. In this scenario, I have shown a storage account and a SQL server. And the idea is that this private endpoint will get projected into a VNet, which is connected to the vWAN hub here. And the flow of interest, right? The main topic of today, the flow of interest, is this VM, which is connected to an ExpressRoute connected branch, is initiating a connection to private endpoint in Azure. All right, so that's the flow of interest. To get this flow to work, there are few things to consider. So like anything with private endpoint, the biggest thing to keep in mind is that anytime you have private endpoints, you have to consider DNS. Okay, so when this private endpoint gets projected behind the scene, there is a DNS, private DNS zone that gets configured. So the DNS resolution from on-prem becomes challenging, right? You need to ensure that that is done correctly. We've done deep dive videos on hybrid DNS, but I'll just show you a quick glimpse of how it should be set up. Basically, this DNS, if you can see the green animated flow is showing the DNS path. So the on-prem DNS, on-prem VM will consult the local DNS, which will have a forwarder to a DNS in Azure, which will in turn consult the Azure DNS, the 168 IP, and which will in turn do the right resolution for the on-prem VM, right? So one thing to consider is this design is showing you an IaaS-based DNS, but of course, best practice should be a private DNS resolver. Keep in mind that our Azure firewall can also act as a DNS proxy, but in this case, we're going to work on Checkpoint. Okay, so that's the DNS flow, making sure DNS is set up correctly from on-prem. And then another thing to consider, and again, remember this is the flow of interest. Another thing to consider is the firewall, SNET, the traffic, right? So when for this flow of interest, out of the box, the Azure firewall will not do any netting. It will bypass. It will not SNAT the traffic, and we'll look at it how it looks like in John's demo as well. So that's one consideration. And the second consideration is there are different type of rules. If you're doing FQDN based rules, this particular device needs to be able to do the DNS resolution correctly, or if you're doing FQDN based rules, right? And lastly, the routing bits, right? So we talked about DNS, we talked about firewalling. Let's look at the routing. So what happens is when you initiate the traffic from on-prem to the private endpoint, because of that /32 that gets injected for the private endpoint, this traffic will go bypass the firewall on the way in, and the return traffic would hit the firewall. So this flow will break. So the way we solve this is using what we call, and I have a couple of screen captures here to show the solution. The way we do, let me just zoom in a little bit more. The way we solve this is using this feature called network policy for private endpoints, and we check this box, and that fixes the issue with the asymmetric routing. And you will also notice that in the and we'll look at it in the demo, but in the effective routing table, you will also see that /32. If you look at a VM in vWAN, you'll see that /32 as well. And I have put, Adam and I are going to do a deep dive video on Azure Firewall. So I have a few screen captures, but we will not be going over this in this session. So with that, I'm going to pause here to make sure, Shri, anything I missed in the scenario, or Cynthia, anything I missed, if you guys want to add, Adam, on the scenario description here.
No, I think you pretty much covered what we needed to talk about it. It is more of how the traffic flow is going to be. Yeah, that's the.
Awesome. So yeah, so with that, I'm just going to double check my notes over here. Cynthia, anything else you want to add here?
No, super clear for me. Thank you. Thank you for the details.
Awesome. So I'm just going to review my notes here to make sure we've covered everything. Yeah, and important thing, routing intent is enabled. Yeah, so I have a screen capture I want to show you here real quick. Or maybe not. Oh yeah, routing intent. So you will see, and we will see this in John's demo, but it is important. So this scenario routing intent is enabled both for private traffic and internet traffic, right? So I did have a couple of flows to share with you. So routing intent is enabled for private traffic. So spoke to spoke will go through the firewall. On-prem to spoke will also go through the firewall. And we will also have internet going through the checkpoint in this scenario. All right, so keep in mind routing intent is enabled, and that's what this icon is. So with that, John, I really appreciate your partnership and you preparing this demo for us on a very short notice. So over to you, and the floor is yours.
Okay, well, hi everyone. I'm going to go ahead and share my screen here. So hopefully you guys can see my screen. Um, so I'll start off with the use case here. So, we have a customer that is, wants to connect to the private endpoint from the branch office. And I just want to highlight the use case here. Is the customer have a site-to-site VPN from the on-prem VPN gateway to the Azure VPN gateway. And then they want to access the private endpoint that is in VNet number 2 here. The endpoint's IP is 10.10.2.5. And and a couple use cases want to highlight. This customer wants to, obviously connect from branch office to their private endpoint, and also wants to connect one of the spoke VNets, which is VNet 1 here, to the private endpoint here. So I'm going to go. So this is the overall architecture. Next, I'm going to jump into the portal to show you the lab configuration. So I want to start off with the virtual WAN. Show you the routing intent specifically for these spokes here. So I'm gonna jump into the hub itself. It's region 1. And you see the third-party providers under network virtual appliance. So we have the checkpoint install, and then the routing intent. We have both the internet traffic and the private traffic routed to the checkpoints for inspection. And so I'll jump one more layer to show you the connections, the connectivity, the virtual networks that are connected to this vWAN hub here. We should have VNet number 1 and VNet number 1 and VNet number 2. So VNet number 2 is where we have the private endpoint deployed, and VNet number 1 is a spoke. So, all right. So now that we have the overall architecture of the vWAN and how the connections are connected to this hub here, next I'm going to show you the private endpoint configuration. So for our testing, we decided to use the storage account. Okay, and it's under this account here. All right, so there are a few settings I want to highlight. First is going to be under the networking. So we have the private endpoint. All right, so yeah, so here I just want to highlight, we have the private endpoint configured, and then under containers we have the storage blob that is for our testing here. So I'll click in here real quick to show you that we have a test HTML file here that we're testing from. And if I click on this guy here, it will show the URL that we're using for testing. Okay. All right. So that's the storage account. All right. So next, I want to show the private endpoint. So next I want to show you the effective routes of this VNet 02 here. So this is the VM inside the same VNet as the private endpoint. So I want to show you the route table with the effective route, what that looks like. So I'm going to jump into this VM here. Actually, it should be this VM here. Hold on. The network settings. This effective routes. So Sorry, I just want to highlight here. So this is the private endpoint route that I want to highlight here is a 10.10.2.5. So from this machine here, I can see that, I do have a /32 route directly to this private endpoint. So, really the traffic will go direct. It will not be inspected by the checkpoints there. So sorry, Nahali, come again. What was your question about the RFC 1918?
So because of the routing intent, we see those RFC 1918 in the effector routes.
Yes, that's right.
And in addition to those, you would see that /32 for the private endpoint.
Yes. Yep. So with the routing intent, we're routing all the traffic to the internal load balancer and then to the checkpoints. But specifically for the endpoint here, the traffic will go direct because of this /32 route. Okay, so now that we have the effective route for the directly connected spoke VM, next we're going to look at the checkpoint security policy looks like. Okay, so I'm going to bring up the smart console here. This is where we define our access control. So the rule here is rule number 5. So essentially, I'm allowing anything from the lab network of all this /RFC 1918 to any, right? So the access will hit this rule. And then also from a NAT perspective, that we don't have to do any NATs for this use case here. So we have a no NAT rule. So any private network to private network, we're not doing any NATing. And then this here, rule number 4 here is for all the high NAT. So anything from the lab network to the internet to anywhere else will high NAT behind our external interface of any of the checkpoints. So this is a dynamic object. So, because we can deploy up to 5 gateways in the vWAN hub. So instead of defining 5 separate NAT rule, we have a single rule that covers the high NAT to the internet. Now, for some PaaS services like SQL, for example, you will require to high NAT behind the internal interface of the checkpoints. So here, just an example rule here. So anything from the lab networks going to a private endpoint, another private endpoint, you can actually also use the dynamic objects that we have. It's called local gateway internal. So whenever packet hits any of the checkpoints, it will try to NAT that traffic to the internal interface. Okay, so that's pretty much the configuration on the checkpoint side. Now, I just want to highlight the fact that we don't have to configure any custom DNS configuration. So we're strictly enforcing the access control based on IP address. So in the case here, accessing the private endpoint, from based on IP address, just define that from the access control. Then we'll be able to enforce that based on IP address. So we don't have to configure the DNS on the checkpoints. Okay, so now that we have show you the configuration on the checkpoint, access control, and the NAT policy, next I'm going to show you the policies, right? So the private endpoint policy. So let me go back to the diagram real quick here. So I want to show you the first test scenario that we have. So for the network policy of private endpoint, there's really 3 settings, right? So it's the disable, where traffic will go directly, bypassing the checkpoints for inspection. There's the network security group setting, and there's a route table, right? So obviously the network security group will go to the NSG, and with route table, we go to the checkpoint. And then there's also an option of doing both the checkpoints and the NSG, right? So this table really highlights the where the checkpoint will come in place for the inspection and where the NSG will come in inspection. So I'll show you the configuration right now. So first we're going to start off with everything disabled. So, and you get to that from the VNet. So here is the spoke VNet where I have the private endpoint deployed, and I'll show you the configuration. So it's under subnets. Click on the subnet itself. Okay, scroll to the bottom where you see network policy for private endpoints. So right now I have this setting as disable. Okay, so what this means that traffic will go direct from my branch office to the private endpoint without the checkpoint or the NSG do the any inspection. So I'm going to show you what that looks like on the wire. Okay, so here is my first. I'm going to act so on the top two. The top two SSH window are the checkpoint firewalls that are deployed inside the vWAN hub. And then on the left here is my spoke VM in VNet 01. And then on the right-hand side was my connecting from my branch office. So again, highlighting this again in the diagram here. So on the lower right is my branch office, where we'll be connecting over the VPN to the private endpoint. And then the top two windows are my checkpoints. And then on the left is my VNet. So I'm going to show you the behaviors, right, of each, right, with the setting disabled. So first, I'm going to connect from my branch office to the private endpoint. So what I'm going to do is I'm going to run a packet capture on the checkpoints just to make sure that, hey, you know, I'm not supposed to see this traffic, so I'm going to run a packet capture to show you that, you know, it is being bypassed. Okay. All right. So next, I'm going to show you. So I have a host file. So instead of configuring DNS, I have the host files that says, hey, connecting to this storage blob, you know, resolve to this IP address. Okay. So now I'm going to run my curl command test. There we go. So as you can see, it was successful. I was able to connect from the branch office to the private endpoint. And in the meantime, you know, I don't see the packet hitting the checkpoints at all, right? So that means it's bypassed. Now, I'm going to do another test, right, which is coming from my spoke VNet, another spoke VNet, which is this guy here, VNet 1, okay? And this traffic will get inspected by the checkpoints because of the routing intent. So I'm going to run a capture for 10.10.2.5 to show you that. Second. 10.10.2.11. Okay. There we go. So wait, hold on a second. I think I can put IP address wrong. Hold on. 10.1.4. Okay, here we go. Okay. So as you can see that this traffic coming from my spoke VNet to the private endpoint will get inspected by the checkpoints. Okay. All right. So this is the essentially our use case number 1, where my policy is set to disable, and as you can see, like, you know, it was bypassed by the checkpoints and the NSGs, right? And obviously, with the exception of, you know, any of the connected spokes will still get inspected by checkpoints, but, you know, but if you're connecting from a branch office to the VPN gateway, that traffic will be bypassed. All right, so I'm just gonna pause here to see if there's any questions.
Yeah, so John, for the completeness of the recording, going back to your in the portal to your spoke VM in question in VNet 1, right? If you could show the effective routes on that one, just so this is the spoke VM on VNet 1.
Yes, so
where you ran the test from.
Yep. So this is the spoke VM number 1. I'll show you the route table there. The effective routes. So this is the route table for this VM here and the spoke VNet 1 here. Okay, so the effective routes. we shouldn't be seeing the /32 route here, and we should see all the routing intent, the RFC 1918 here, but we don't see the the bottom. We don't see the private endpoint /32 route here.
All right. And then one more thing, if you go back on the console of that VM, this particular VM, just wanted to, so there is no, if you do a more on the etc host file, there is no entry here because we're leveraging the private DNS zone. So maybe we show that link to the, so if you go to the private DNS zone in Azure.
Okay, so in this case, I do have the
you did put
the host file. Yeah, I did put the host file here. But I can.
Okay, I'm wondering. Well, let's look at this as a good thing to show. So let's leave it there. Let's go back to first look at the private DNS zone.
All right, so we can help me navigate.
Yeah, so search for private DNS zone right there in the search bar. Yeah. Yeah, that one. And then let's pick that and look at the expand the DNS management on the blade.
Mm-hmm.
Yeah, so you do, is this one of your VNets in question?
So
is this
yeah,
the
this is the first and the second VNet. So the private endpoint is actually inside this VNet here.
And what about the other one? These VM that you're running the.
Yeah, this one is the VNet 1 spoke.
Yeah, so if you don't need the host file entry, so click on that VNet just to double check your. Yeah, so that's the, so actually go, I think we'll have to navigate through the VNet.
Oh, go directly from VNet itself.
Okay. Yeah. So just want to make sure we're looking at the right VNet. Yeah, that's the VNet, right?
Mm-hmm.
Yeah, so here, if that's the VNet, then we don't need, so maybe we should run one more test without that entry, the host entry in the spoke VNet, because it's directly, it has a link to the private DNS zone. So
okay. So I can get rid of this guy here. And then
you can run the curl command again.
Yep.
Yeah,
it's still working.
Yeah. So the idea is that in Azure spokes, we can link the VNets to the private DNS zones, but for on-prem, of course, in production, you wouldn't put it in the host file. You would have like some sort of private DNS resolver or hybrid DNS, like we talked about earlier in the session. But for now, we did the etc host file entry. So I see Daniel on the call. Daniel, any other question or anything you want to call out in this scenario?
Yeah, I just want to point out that for this specific scenario, we only support a route intent with private endpoints when you have the UDR network policy at subnet level.
Right, and I think that's the next scenario, right, John, for us?
Yeah, so the next scenario I want to show you guys is the route table only. So when I jump into the private endpoint subnet, I'll set the route table only. So what we did just now is have it all disabled. So next I'm going to show you the next one here, which is a route table only. And what that means is that we'll have that inspected by checkpoint. What Daniel mentioned earlier is that, hey, if I set the route table, then it'll be getting inspected by checkpoint. But however, we'll still bypass the NSG. So let me show you that setting right now and show you some of the packet captured and the checkpoint firewall logs for my testing. And I'll be testing this directly from my branch office to the private endpoint, okay, with this setting. So, all right, so I'm gonna jump into the portal. so I'm going to jump into the VNet with the private endpoint, which is my VNet 2 here. It is under subnets. Okay, so subnet 2 is with my private endpoint. If I scroll to the bottom, right now the private endpoint network policy is set to disable. I'm going to go ahead and set route table only. And you can do both, right? So I'll show you that later on in another test there. So right now, route table only. So as that's happening, I'm going to jump back into my SSH connection to my checkpoints. So here, I will run another packet capture. And this time I will look for access coming from my branch office IP, which is 1021.4. Okay. Okay, so just double checking, make sure the change was successful. Okay, so yep, so it looks good. So next I'm gonna run the curl command, and I should see the packet hitting the checkpoints now. Okay, so yeah, there we go. So on the left-hand side, you can see the traffic coming from my branch office now hitting the first checkpoint gateway, and whereas before this traffic was bypassed. Right, so yeah, as you can see that now it's going to the second one because of the 5-tuple internal load balancer. So, all right, so that's my test for this guy here. So, which is a route table only. So I'm just gonna pause here for any questions from Nahali and Daniel before I move on to the next test where I will bypass the checkpoints and have it inspected by NSG only.
Just a quick comment that this wouldn't have any effect on that other VM that we were testing it from, right? So that would continue to work.
Correct. Yeah. So the other VM on the left, which is the my spoke VM in VNet 1, that will continue to work, right? Regardless of the policy setting that I set.
So that's only applicable for, like Daniel mentioned earlier, from on-prem to the private endpoint. We have to have that routing enabled.
That's right. Yep.
Yeah, and I'll put the link in the chat in the description below that explains this in our official Azure documentation as well. We've called this out.
Okay, cool. Okay, so I'm going to move on to our third test, which is here. We're going to run the network security group only. So we're going to bypass the checkpoints now, and then we're going to get inspected by the NSG here. So to make that change, now go back to my VNet. Okay, and at the bottom here, I will set to NSG only. Okay, save. Okay, so while that is saving, I will also show you what my NSG looks like. So you define, so we have an NSG here assigned to this subnet. Under my inbound rules, I have HTTP and HTTPS. Okay, so essentially allowing access to the private endpoint. Okay, so it looks like the change was successful. Okay, so now if I run the test again, I shouldn't be seeing packet hitting the checkpoint. Okay, so run the curl command. All right, so it's still successful. However, we don't see the packet hitting the checkpoints now. Okay, so this is the test number 3, where the enforcement is NSG only. Okay, so I'm going to move on to our last test, which is we can have both the route table and the NSG enable, and it will be inspected by both the NSG and the checkpoint. This is generally, our recommendation is to have both the NSG and the checkpoint. So, obviously the, NSG will be doing the first layer of inspection, and anything that, with the higher level of security will have the checkpoints for the inspection there. Okay, so the I'll go back to our portal. Okay, so we'll go back to the subnet itself. And I'll enable both the route table and the NSG. Okay, so should be okay. So that was successful. So now if I run the test again, the traffic is going through both the NSG and the checkpoints for inspection. Okay, so you can see it was going through my gateway number 1, number 2. Yep, and there we go. Yep. So now it's getting low bounds between the 2 checkpoints, and I can also jump into our smart console, show you what the logs looks like. Let's do a quick refresh. All right, so that was the log entry. So as you can see that, it's coming over from a VPN gateway to the CloudGuard gateways inside the vWAN. And here's a log entry for it. So traffic coming from my branch office to the private endpoint is hitting NAT rule number 3, which is the a no NAT rule. So sorry, going to NAT rule number 3, and which is the no NAT rule. So any internal to internal, we don't have to do any NAT. Now, again, if you are accessing endpoints that requires a high NAT, you enable NAT rule number 5 specifically for that. All right, so that's pretty much highlight all the different test scenarios, right, with the network policy for private endpoint. Just gonna pause here before I go into my last slide here, which is highlighting other use cases here. Any questions, the team?
So John, one question. If you show the NSG again, I just want to call out just for extra emphasis here. So if you show the NSG,
Yep.
Right now it's set to allow, and it's associated. If you show the subnets, it's associated with the on the left navigation pane. If you click on the subnets, it's associated with the private endpoint.
This one right here.
Is this where your private endpoint is?
Yes, yeah. So it's 10.10 2.0/24.
Yes,
that's
so that's
yeah.
I just wanted to call out that it has to be associated with the private endpoint, wherever the private endpoint is deployed. And then a quick point, if you go to the architecture diagram, I think Daniel and I discussed this before, but Daniel, did you want to call out the fact that this behavior that we saw with from branch, a VPN connected branch to the private endpoint, right? When that setting is disabled, it bypasses it. But I know you had seen some different behavior with ExpressRoute connected branch, right?
Correct. We have a different behavior if the branch is connected over ExpressRoute. So, which in this case, if you have that as the policy disabled, it's going to be always asymmetric routing, and the perception from the branch is going to be like is not going to be able to connect to the private endpoint. So we do have 2 different behaviors. VPN is always a bypass with that policy disabled, but with the ExpressRoute we have asymmetric, which is going to it's not going to be a bypass in this case. It's going to be always a block, right? So just want to highlight that different behavior as well for the ExpressRoute.
So Daniel, I think you bring up a great point because our customer had reported that behavior, and Adam and I tested this using our Azure firewall. We had an ExpressRoute connected branch, and it was getting asymmetric. So I think that kind of aligns with what we saw with John with the checkpoint and and an ExpressRoute connected branch as well. Okay, so that was where the traffic would get asymmetric.
Yeah, thank you for highlighting that. So for, I guess, for the ExpressRoute customers, definitely should have, instead of have it disable, have the route table only, make sure that is get routed to the checkpoints properly for both to complete the, three-way handshake, make sure that, we're seeing all the traffic as opposed to the asymmetric traffic.
Yeah, and we have another video with Azure Firewall highlighting exactly what Daniel has mentioned. So be sure to check out that video in which we have an ExpressRoute connected branch. Of course, we don't have a checkpoint, but that behavior still stays. So great call out, Daniel. Appreciate it. Thank you.
My pleasure.
Okay, so I also want to highlight a couple more use cases on the checkpoint and to wrap this up here. So with checkpoints, with the private endpoint, we're doing layer 3, layer 4 packet inspection. So we do support with direct ingress. So that means that from the internet you can still host the private endpoint from the internet for specific access, like from certain IP addresses or certain users, right? So we do support the direct ingress to access the private endpoint. We also support client-to-site VPN and site-to-site VPN. So meaning you can establish the site-to-site VPNs directly to the checkpoints inside the vWAN hub, or you can also use the client-to-site VPN as well to control who has access to this private endpoint. So this is really in addition to the two use cases what we just demoed earlier, which is the VNet accessing the private endpoint and also the branch office, but we also support these 3 additional use cases here as well. Okay,
I see. So the first use case, John, that you showed us earlier, the VPN was terminated on the VPN gateway, the Azure's VPN gateway, but you also support termination on the CloudGuards.
Yes, yep, that's right.
Now, this is coming, I have one more question, mostly coming from the way we do this in our documentation for Azure Firewall. We have 2 types of rules, network rules and application rules. So I know you touched upon this before, but do you have anything documented for checkpoint, for FQDN or application-based rules?
Yeah, it's a great question. So for PaaS services, we do have an article highlighting, how Checkpoint can protect the PaaS services, right, using CloudGuard network security. Now, specifically for FQDN, etc., right? So we don't need to configure the private DNS for the PaaS services. So because we're inspecting based on IP address only, so we don't have to configure the DNS entries on the checkpoints because we're inspecting by IP. So we're not, the checkpoint itself is actually not doing the lookup, not serving like a reverse proxy, if you will.
I see. Yes.
Hope that makes sense. Yeah.
Right. No, definitely. So I think from a DNS perspective, hybrid DNS is the setup that people should do for either a site-to-site connected or an ExpressRoute connected branch. I think Daniel has written some amazing blogs on that hybrid DNS setup. So I'll put the link in the description below. So be sure to check that out. But I think that covers it. Anything else, Daniel? You have any other question, John, before we close?
Okay.
I'm good. Thank you, Nihali.
Excellent. Well, thanks everyone for joining, and thanks, John, for showing us this awesome demo, creating this whole lab on a very short notice. This was really useful. I hope you all enjoyed the session, and we will see you in the next video.
Thank you.
Thank you.